Hello, Shahab Ahmad here. We welcome you to the channel Defying Mediocrity. And now we are in the chapter States of Matter Gases. So in the gaseous chapter, first of all, we will discuss laws. And the first for today's discussion is Charles' law. So according to Charles' law, there is a relation between volume of a gas and its temperature. So according to Charles, for a fixed amount of gas at a certain pressure, its volume will be directly proportional to its temperature. Okay, so in other words, V over T would be equal to constant. The ratio of volume or temperature will be a constant value. So if I were to plot a graph of volume versus temperature, I would get a straight line giving me an isobar. As I said in the postulate of this theory, of this law, that there must be number of mole must be constant and the pressure of the gas must be constant. So at constant pressure, for a certain amount of gas, the volume of that gas is directly proportional to temperature. If you increase the temperature of a gas, its volume also increases. Okay, so this was the relation. Now, another thing I could observe that V over T is equal to constant. For every value of T, you will get V over T is equal to constant, even if you were to change temperature or volume, okay, any of that. Suppose you were to plot a graph of V over T versus T, what would you get? You would get a straight line because its value is not changing. It is constant. So you will get a straight line horizontal to the x-axis. This is all about it. So now we will come to the MCQs and solve it with the help of it. The first MCQ is saying, in Charles' law, which of the following are variables? So what are the variables? Volume and temperature. Volume and temperature. Okay. The second question is, for ideal gas, isobar is, what is isobar? Isobar is P versus V versus T at constant pressure. So V versus T, the line of the slope of V versus T graph at constant pressure is isobar, because we have taken iso mean same and bar mean pressure. So we are taking the measurement at constant pressure. So the V versus T graph will give us an isobar at constant pressure. Okay, now the third one, which of the following plot gives a horizontal line? So we can see V over T at constant temperature will give us a horizontal line which is parallel to the x-axis. So V versus T, V over T versus T gives us a horizontal line. So the Charles idea of a linear relation between the volume and temperature was extrapolated by Kelvin, and he came up with absolute zero and an absolute scale for temperature also with the Kelvin scale. So he said that, but that is not of our importance. That is the topic of thermodynamics. But here we will see that for the gases, there is a relation between the volume of the gas and temperature rise and fall of the gas. So Kelvin said that for every degree Celsius rise and fall in temperature, you will see the volume change, the original volume change by 1 over 273. Okay, you have the original volume of V naught. You will see it change by V naught of 273 multiply with the temperature change you got. Okay, so this is the theory of Kelvin. Now, we must put some values over here. Suppose I were to put a value of temperature. Suppose I change the temperature from 0 to -1. What will I get? I will get, suppose my initial volume was V naught. V naught remains the same, over 273. and I change the temperature to -1. So I'll multiply, -1 will get multiplied with the whole figure. I'll get minus V naught over 273. Suppose I was taking the volume in ml, so I will get this as my equation. Now, suppose I were to change the temperature to minus 273 degrees Celsius. Okay, I change the temperature to minus 273 degrees Celsius. What will I get? How will this change this equation? I'll write it over here. So suppose my initial volume was V naught, and this will remain V naught over 273 into minus 273. Okay, because I changed the temperature to minus 273. This is plus. So what will I get? 273 cancelled out with 273 minus multiply with plus will get us minus. Okay, so what in the end will we get? V naught minus V naught, 0. So this means the volume, even though I had some initial volume of V naught, so the initial volume now vanishes. At minus 273, the volume becomes 0. Now after this discussion, we will solve these questions. The first one is saying if the volume of a gas at 0 degrees C is V naught, okay, this is V naught, then volume of the gas at -1 degree Celsius at constant pressure will be. So what will be the volume at -1? So we solve it for -1. This will be V naught minus V naught over 273. V naught minus V naught over 273. So option C. Okay. The next question is the temperature at which the motion of the molecule ceases is called. So this temperature minus 273 is called absolute zero, because at this state all the motions of the molecule ceases, stop. Okay, cease means stop. So all the motions stops. Okay, all the motion of the molecule stops. So this temperature is called absolute zero. Okay, absolute zero. So the third question is which of the following is zero for a gas at absolute zero? So what is zero for a gas at absolute zero? Because it is motionless and its volume is zero, so its volume will be zero and its diffusion would also be zero because it is motionless. So we will have our answer is both A and B.